Hello everybody. एक मिनट बघतो. Hello everybody. Now our problem statement is that a situation in an electric scooter company. Basically nowadays the electrical vehicles are demanding and electrical scooter are also demanding. The company is
हे परत चालू कर आवाज.
So, hello everybody. Our problem statement is that a situation in an electric scooter company. Nowadays, electrical vehicles are very demanding, and the electrical scooters are also demanding. So, our motive is that to solve the problems related to the electrical vehicles. What are the data they are using for electrical vehicles? So, we are manipulating all the data and the concepts regarding the electrical vehicles. So, my name is Yash Chavan, and this is my teammates. So, next slide. So the first question is that the company would like the app to have intelligent and provide recommendation to the driver. So basically, the intelligence provided by the company to the driver, what kind of the data should the app collect from the vehicles, and we are using the ML and AI algorithm for this. So what are the precautions that will be taken in the format of the GPS locations, ride durations, vehicle types, and braking systems. So this is the collecting of a data in the save of battery.
अरे नको ना येऊ काय कर लावलं काहीतरी. ए सॉरी.
Basically, hello. Basically, we are talking about the challenges faced by the electrical vehicles in the nowadays. So, what are the precaution or what are the prediction that we are analyzed through the AI and ML model? So, there are some 2 points in this we are discussing about that to make the app smarter and reachable for the everybody. So, it takes the GPS location, ride duration, and in many other braking systems. So, collecting the data in the app is very smart solution given by the engineers in our daily life. So it is a most important in the electrical scooter is that low battery alerts. So it helps to conserve the energy in the form of traveling or in the form of any other concepts. The next slide. So next problem statement or the question is that the company is collecting the data in the cloud already, but have a good performance in issue to the update and collect data. So what are the reasons behind this? The performance basically the data will be collected in the form of networking connections, insufficient backend systems. These are the problems which the cloud system or cloud computing faces. So to improve this company, should be data should be optimized in the clear format and consider the edge computing and upgrade this their cloud setup and based APIs for this. And basically, we are facing the lot of data storage and data cloudness in the system. So we are taking this into the discussion of making the product reliable or optimized. Next slide. Explained by Yash Shinde.
So as of the problem or the question in this slide is the company wants to do analysis. Array. So the next question is that the company wants to discuss an analysis of an app that needs an improvement in it, and there are certain mind maps or top 10 features which you need to understand in the app of for the electric scooter, and we have to explain what are the top 5 features which will be most useful for an electric scooter in to build the app. So there are top 10 features. As we know, battery monitoring, it will display the real time battery percentage and its health. There is the feature of GPS tracking. There are features of security features which consist of app lock regarding keys lock and remote shutdown. It consists of a ride statistics. It means it will give the average speed, average CO2 consumption or emission which is saved to preserve the environment. There are certain service reminders, means when there is a need to have a service for any car. There is charging station locator, means it will display the nearest charging station for electric vehicle. through the GPS. There will be a payment integration. Also means it consists of recharge plan for a pack, which consists of a reverse charging or reverse gear, or consists of a swift mode, which may enhance the performance of the electric vehicle. There will be user preferences or user profiles, so that it will consist of the information of how much distance has the user covered and how much ride modes are available for the user. Next up, there will be notifications and alerts, which will display whether the battery is low or high for a particular ride. It will display the theft, or it will display whether the charging is done or not. And there are smart AI tips also included within the app for an electric vehicle, which consist of ride efficiency. There are also battery saving suggestions. Again, the next top 5 features which are very useful, which I want to discuss, is this consists of battery monitoring, GPS and vehicle tracking. Also similarly, the charging station locator. There are mostly the useful and security features available, which add safety and remote control functionality. There are service reminders, which are very important for time to time maintenance and time to time service of an electric vehicle. So the next question which I want to discuss is, what do you think the business metrics which are given by a used company to decide what to focus on, and what the necessary improvements and the changes are, and what are the special engineering metrics and measurements that we should think to be considering the complaints for the customers, and we have to give specific reasons for those metrics and measurements. So the answer for this is, company uses business metrics which has active users. This consists of their retention rates, completion rates, and app crash rate, whether the app is crashed or not. And customer satisfaction plays a key and important role. And also it consists of a support ticket volume to prioritize the improvements. These indicate the user engagement, reliability, and service quality. From an engineering perspective, as we all know, we are engineering students, the metrics like API response time, cloud data, sync latency, and data packet loss for the vehicles play a very crucial role for the backend errors, and these directly impact the customers experience. We know that the customers will have a very low they do not care about the backend processes, but as an engineering student we all know that these API responses play a very crucial role, or if any kind of missing data often stem from these technical issues are missed, then tracking this ensures both performance and user satisfaction, which provide hand to hand. So next slide will be explained by Gaurav.
ऐक ना 2 मिनिटं हे करता का म्हणजे मी हे करून जरा घेतो प्रिपेअर. So what are the business and operational metrics and measurements the company can use for the new version of vehicle and the goals they have for it? Business metrics can be around revenue, profits, etc. While operational metrics can be around quality, delivery time, etc. What all can be the metrics which companies measure their performance and manufacturing and selling electric vehicles? So business, first one is revenue growth rate, market share price, the average selling price, gross margin per unit, return on investment, customer acquisition cost, CAC, and net promoter score. The operation, production cycle time, production cost per vehicle, defect rate, first pass yield, on time delivery rate, supplier lead time, warranty claim rate, energy consumption per unit, sustainability index, and software stability. So if you want to write detailed test scenarios for testing the battery of vehicle, what all would be the top 10 to 20 scenarios? Create a mind map and do a relative priority of the test scenarios based on most important to least. Safety, crash test, battery test, water test. In efficiency, there is capacity test, power discharge, peak power capability, and DCIR measurement. Again, durability, temperature cycling, humidity and altitude, cooling system efficiency, life cycle durability, and aging effects. Here, software SOH algorithm validation, BMS communication and fault detection, and abuse, overcharge, short circuit, vibration and impact, and resistance. A further slide will be explained by Shreya.
So the next problem segment is list the potential reasons for any two of the issues which the customers have complained about and write the test scenarios you will use to test and ensure they have been fixed. Issue 1. So limited range anxiety. So as we travel, use electric vehicles, there is the range anxiety. So reasons are cold weather reduces range by 19% at 20 Fahrenheit. Range estimates off by 10 to 15% due to inaccurate algorithms. Text scenario, cold weather range. Objective ensure that less than or equal to 80% of 330 mile per range, 264 miles at 20 degree Fahrenheit. Setup 2025 Tesla model Y 100% SoC, 20% chamber, BMS V12 3.1. Steps drive 100 miles, 60% highway, 40% city, 65 to 35 miles per hour. Sorry. Use heater 70-degree fan. Headlights record SoC at 10 degrees. Check range estimates accuracy is less than or equal to 5% deviation. Expected result is greater than or equal to 264 miles. Estimate within 5% to 12 to 13 miles. Pass or fail. Pass if range is greater than or equal to 264 miles. Estimate accurate. Change this. Second is the list the potentials. Second issue that is charging issues. Issues 28% of owners face charging failures. Reasons are software glitches, stop charging at 80%. Faulty sockets cause intermittent failures. Test scenario, software driven charging. Objective, confirm 100% SoC without interruptions. Setup 2025 Hyundai Ioniq 5, 20% SoC level 2. Steps are the charge to 100% on level 2, monitor SoC every 15 minutes, repeat on CCS 80% in 18 minutes, 100% if supported. Log errors over 5 cycles. Expected result 100% in 7 to 8 hours, level 2 80% in 18 to 20 minutes. No errors. Pass or fail. If pass if 100% SoC, no interruptions. Change the slide. Research on the evolution of the domain of electric vehicles and represent it on one slide in an impactful way on what has been the evolution and where you think it will be 10 years from now and what kind of feature functions will be available. How has the technology evolved and what is the future direction of the technology. The evolution of electric vehicles, past, present, and future. Timeline. Past. Since 2000 to 2015, the dawn of EVs. 2008, Tesla Roadster launched. 2010, Nissan Leaf for mass market. Take 100-mile range, basic regenerative braking. Emitter chargers. Present 2016 to 2025, mainstream adoption. 2020, 10 million global EVs, 4.6% sales shares. 2023, 40% sales growth, Tesla 20% market. Features ADAS, OTA updates, V2G charging. Future 2026, 2020, 35. Electric revolution 2030 40 to 50% global sales, 26.4 million EVs in US. Tech solid state batteries, 750 mile range, 10-minute charging. Direction $25,000 EVs, 17-minute charge, renewable energy integrations. Thank you. That's what for today's.
So at last, we are the team RAW. We are signing off.